Let us solve question 6.5.1, wherein we are given a matrix, 2 cross 2 matrix. Okay, and we have to find eigenvalues and corresponding eigenvectors for the same. Okay, so given 2 cross 2 matrix A 2 4 1 2, to find eigenvalues and eigenvectors. Okay, now solution. So the way we find eigenvalues is, first we make a characteristic equation for the given matrix. So let's first make the characteristic equation, that is determinant of A minus lambda E equals to 0, that is 2 minus lambda 4 1 2 minus lambda equals to 0, that is 2 minus lambda whole square minus 4 equals to lambda square minus 4 lambda equals to 0, which gives me one eigenvalue as 0 and other eigenvalues as 4. Okay, now for lambda 1 equal to 0, A minus lambda 1 E, let h1 be my eigenvector for lambda 1. Okay, so what I get is A minus lambda 1 E. So I basically get the A matrix itself. So it is 2 4 1 2 h11 h12. So these are the components of that vector, that equals to 0, and both of this gives me a equation h11 plus 2h12 equals to 0. And if I keep, so let's keep my h12 as 1, which implies it will give me my h11 as 2. So my eigenvector will become 2 minus 1. Okay, and for lambda 2 equals to 4, my eigen equation will be something like A minus lambda 2E h2 equals to 0. So minus 2 4 1 minus 2 h21 h22 equals to 0, and that gives me an equation h21 equals to 2h22. So one thing you need to know, that these 2 which I am 2 or 1 which I am putting over the superscript as superscript, these are not squares, these are just notation that I am using as of now. So my h2 becomes 2 1, because I have kept my h22 as, let h22 will be my 1, then it gives me this as eigenvector. Okay, so for lambda 1 equals to 0, my eigenvector is 2 comma minus 1, and for lambda 2 equals to 4, my eigenvector is 2 comma 1. And one thing that is given as note in the question, that the two eigenvectors are orthogonal, so that is their inner product as 2 comma minus 1 2 comma 1 is, they are not orthogonal, sorry. So that gives me as 4 minus 1 equals to 3, and since it's not equal to 0, it tells me that they are not orthogonal. I hope I could explain question in a I can explain this question briefly. Thank you for watching the video.